In this section, we were going to discuss the prime numbers, and in particular their properties that are relevant to the development of RSA cryptography. So prime numbers are those positive integers which are only divisible by themselves and 1. In other words, those positive integers which cannot be further factorised. It's also conventional and useful, as we'll see later, not to include 1 amongst the primes. So in that case, the first prime is 2, the next is 3, not 4 because that's 2 times 2, 5 is prime, 6 is not because it's 2 times 3, 7 is prime, 8 is not because it's 2 times 2 times 2, 9 is not because it's 3 times 3, and so on. 11 is the next prime, 13 the next one after that. We're also going to see that there are infinitely many primes, and that, in a sense I'll remark on a little bit later, are relatively common. Primes are the atoms, if you like, or the building blocks for multiplication. Every positive integer can be written as a product of primes in essentially one and only one way. From the point of view of RSA cryptography, the following computational facts are going to be very relevant. So, for example, we're going to be dealing with prime numbers which are 150 digits or more. Now, primes are actually quite easy to find, and they're also very common, as I mentioned before. If you look at the primes which are 150 digits long, then amongst all the numbers 150 digits long, and this is such a number is far larger than the number of atoms in the universe, then roughly 1 in every 345 is prime. So I could, for example, type out 150 random digits and ask Maple, or Maple being a computer program, to tell me the next prime after that. It will probably only have to check about 345, 350 or so, and it'll find a prime, and it'll find it very quickly. It'll do all of this in about a second or so. So primes are easy to find, but on the other hand, if I take 2 such primes, 150 digits long, and multiply them, I'll get a number 299 or 300 digits long. And it is impossible, essentially impossible, in the lifetime of the universe with current computing technology to find those 2 factors, except for me, because I knew what they were. We're going to also discuss the division algorithm, which is just a way of formalizing division. And we're going to discuss the Euclidean algorithm and the extended Euclidean algorithm, which are methods for finding the greatest common divisor of 2 integers and for expressing that greatest common divisor as the sum or difference of multiples of those 2 integers. This is going to play an important theoretical role also in the development of RSA cryptography. And finally, I mentioned before, Euclid's Elements, written circa about 300 BC. There are 13 books. Of course, it was written on a manuscript papyrus. Geometry, algebra, and the axiomatic method are all in there. That's been published in over 1,000 different editions. It was used extensively in universities and schools up until about 1900. It's fundamental to Western mathematics and science, and it has more editions than any other book except for the Bible.